Over the last 20 years or so, and certainly in the last 10 years, Python has become an extremely popular programming language in a lot of fields outside of software development. This means in fields like physics, maths, chemistry, astronomy, data science, many different scientific fields which aren't necessarily focused on software development or computer science. And it got to this stage because Python is quite an easy to learn programming language. The syntax is simple, it has many different packages which can help with different use cases, and it has tools such as Spyder and Jupyter Notebook which make it a bit more usable in certain scientific applications. One of the problems that arises, however, when users of Python haven't been properly taught how to program or haven't been given a certain amount of background knowledge that would be assumed of a computer science student or a software developer, is that people run into some very common issues with memory management and with performance. So I'm making this series to talk a bit about how Python actually works so that you can better write performant code that will avoid these common issues that people run into. So firstly, what actually is Python, or rather, how does Python run on your machine? So Python is what we call an interpreted language. Now, this is in contrast to a compiled language. An example of this would be C, and this is the comparison I'm going to be making in this slide here. With C, which is another high-level programming language, you would write your human-readable C file, pass this to a compiler, and the compiler translates this into machine code which your processor can then read. So there's a direct translation from your C file into what the processor is reading, and when you execute that binary file out the end, that machine code file, that's running directly on your hardware. This isn't how Python works. Not quite anyway. With Python, your human-readable Python file gets passed on to something called the Python interpreter. So if you type Python into your terminal on your machine, you'll be met with the kind of live Python shell, which is a form of the interpreter. Or if you type Python and then give it a file name, that's you passing your file into the interpreter. So there are a number of steps which the interpreter handles here. So firstly, it compiles your Python file into bytecode. Now, you probably don't need to know too much about how bytecode works. Not many people do much work with it. It is technically human readable. You could open it in a text file. However, like I say, most people just work with their Python files. This bytecode is then fed into the Python virtual machine. The VM, virtual machine, is what's running on your processor. So that's kind of the machine code layer, which is using your Python file to pass that on to the processor. This is just something to be aware of when you're writing Python. There's always going to be somewhat of a bottleneck whenever you're running Python code in comparison to a compiled language, because you have this multiple translation layer whenever you're running this. But what I will say is that this is not the only source of performance issues in Python. This is something that a lot of people talk about. They'll say, oh, Python's a slow language, and in many ways it is, but a lot of that is down to how you're writing your programs or how you're writing your scripts. So what I want to talk about next, or introduce to you, are the kind of low-level basics of computer programming. Firstly, let's talk about memory, because I think this is a topic which is vastly overlooked when people are first introduced to programming. Your computer has what's normally known as RAM, random access memory. Now, nowadays, I think most laptops will come with about 8 gigabytes of RAM. Some will come with 16 if they're more kind of business focused. And this is a number that's always changing, right? So when I was growing up, you would get laptops with 2 gigabytes of RAM. Windows could run on 500 megabytes. But as computers advance and as operating systems change, these numbers just keep going up. But what doesn't change is that anytime you want to store a variable in your program, this is going to use up some of that memory. So I've drawn a diagram here. If you just say to your Python interpreter, if you have just a blank file that just says a equals 5 and you run that, while that program runs, the interpreter says, okay, we want to store this as a variable. Whenever we say a, that means 5. That has to be stored somewhere in your computer's memory. It'll allocate a certain number of bytes of that memory to remember a equals 5. So when we come later down the line and say, okay, print a, the interpreter has to read from the memory and recall that a was 5 and it'll print out 5. This should hopefully seem fairly basic, but what I'm trying to get at here is that every single time you create a variable or populate a variable, that's going to increase how much memory you're using. So if we're looping over hundreds of thousands of iterations and say appending to a list or creating, if you're doing nested loops where you're creating many arrays and you're not emptying those arrays, your memory usage is just going to keep going up. And what you get to eventually is what's called an out of memory error. So say I have like an 8 gigabyte file on my hard drive and I try to load that entire file into a variable in my program. If my PC only has 8 gigabytes of RAM, that's just going to fail. So there are techniques in order to get around this and improve how your program works. That's something we're going to cover later on in the series. And so here I've just shown whenever your program exits and the Python interpreter closes, that variable is gone from your computer's memory. It can't be accessed anymore. So this is why if you've been in a Jupyter notebook before and you have, your first cell assigns a variable and your second one uses it, if you close the Python kernel and then try to run only the second cell, it doesn't know what it's reading because you haven't, whenever you close the kernel, it's deleted all those variables from memory and you need to load them back in each time. So the key point here is variables use memory and memory is finite, so you can't have infinite variables. So the next topic I'm going to touch on here is data structures, and I've got the tagline here, choose the right one for the job. And I say this because Python offers many different types of data structures. You can create dictionaries, lists, tuples, arrays, data frames, the list goes on, pardon the pun. And there are also third-party formats that you can use as well, from NumPy and from Pandas. There are just endless ways that you can store data in Python. And the important part to note here is there are different ways to do the same thing. Some ways are better than others. This is going to be a common theme throughout the series. So, yep, that's coming up in the future. We'll do a deep dive into data structures and when you should use each type. The next point I want to touch on is what I've called here algorithm efficiency. So, much like the data structures, there are multiple ways that you can perform certain operations within Python. There are a number of built-in methods you can use. There are a number of more manual, low-level ways that you can do things. And which method you decide to use can have a massive impact on performance. This one's less about running into out-of-memory errors and more about just the time it takes to run your program. If you're doing data science or astronomy and you're working with massive data sets, this is where small tweaks in efficiency can make a huge difference. It can be the difference between running your program for a day versus a few hours. And this is something, again, that I feel probably isn't taught that well or isn't communicated that well in certain fields. And often, if you're not sure what to look for, it can be really difficult to know which method is going to be faster than the other one. And so that was just a quick summary of some of the topics that I'd like to cover. This was just a quick introduction. I hope it's given you an idea of what's to come and a bit of an understanding how the Python interpreter works. Next episode, I'm going to go a bit deeper into memory management in Python and maybe show some practical examples of what you can do to improve your memory management when you're working with larger files and larger data sets. Thanks for watching. Hope this has been helpful, and I'll see you in the next one.